Good morning to one and all. Today I will discuss about the topic is network theorem. That is also one of the maximum power transfer theorem. Okay. What is meant by maximum power transfer theorem? The original of two terminal circuit, it is replaced as Thevenin equivalent circuit across the variable load resistance. So that network or that circuit, it can be converted into the equivalent circuit. That equivalent circuit, you have one VTH voltage source and one RTH voltage source and one more resistor, that is the load resistance. So what is meant by maximum power transfer theorem? When the source resistance is equal to load resistance, at that time the circuit have transferred the maximum power. Okay, maximum power. Okay, the current through the load for any value of load resistance equal to IL. So what is the value of IL equal to VTH divided by RTH plus RL. So what is the power observed to the load? So power observed to the load is equal to PL, P is equal to I square R formula. E here power observed to the load. So PL equal to IL square into RL. So what is the value of IL square means Thevenin voltage by divided by Thevenin resistance into RL whole square into RL. Okay, so maximum power transfer theorem. From the above expression, the power is delivered depends upon the value of RTH and RL. However, the Thevenin equivalent is constant. Power delivered from the source resistance is equal to load resistance. This depends upon the load resistance. To find the exact value of RL, to apply the differentiation with respect to RL and equal to 0. So, you know already PL formula. So, with you know the PL formula means power in load. You derivative the power in load with respect to RL. So applying the derivative, so last and final RL equal to RTH or otherwise RS equal to RTH. Source resistance is equal to load resistance. At that condition, the maximum power is transferred from source to load. Therefore, the condition for matching load resistance equal to load where the maximum power is transferred across the load resistance equal to Thevenin's resistance of the circuit. By substituting RTH is equal to RL, we got P max value. So what is the P max maximum power? So you know already VTH square divided by RTH plus RL whole square, that is the IL formula into RL. So substitute here VTH divided by RTH place replacement of RL is equal to RTH. So P max formula is equal to VTH square divided by 4 RTH. Okay, so the total power transferred from the source is equal to IL square into RTH plus RL, or otherwise 2 IL square into RL. The efficiency under the condition of maximum power transfer is the efficiency is equal to output by input into 100. So IL square RL divided by 2 IL square RL into 100. So efficiency of maximum power transfer theorem is equal to maximum efficiency equal to 50%. Hence, the condition for maximum power transfer, the efficiency is 50%. That means of percentage of generated power is delivered to the percentage of power delivered to the load. The load and other condition of load and other conditions. Okay, so this is the before we will discuss about the DC circuit. Now the same theorem is applied for AC circuits also. It can be started in active network. The maximum power is transferred from source to load. Source to load, but here the load is equal to impedance is equal to here the impedance is equal to complex conjugate, and equivalent impedance is given by the network at the load terminal. Consider the Thevenin equivalent circuit across the load terminal, which is current flowing through, given by I is equal to VTH by ZTH plus ZL. Here ZTH means impedance in Thevenin's equivalent impedance, ZL is equal to load. Okay, now where ZL is equal to RL plus JXL, ZTH is equal to RTH plus JXTS. Therefore, you substitute this value in the above equation. What is the power delivered to the load is equal to PL equal to IL square into RL. Okay, so PL is equal to IL square. For the maximum power is derivative of the above equation must be 0. After simplification, we get XL plus XTH equal to 0, or otherwise reactance of load equal to reactance of TH equal reactance of load equal to minus of reactance of XTH. Putting the relation in equation number 1. So power is equal to RL equal to RTH. Hence, the maximum power will transfer from the load to source, or otherwise RL equal to RTH, XL equal to minus XTH in AC circuit. In that, this means the load impedance should be equal to the complex conjugate of an equivalent impedance of the circuit. So, ZL is equal to ZTH, but ZTH is equal to complex conjugate of an equivalent impedance. The maximum power transferred is equal to, here the formula of VTH square divided by 4RL, same as it is in AC circuit as well as the DC circuit. So example problem. Consider the below circuit to which we determine the value of load resistance that receive the maximum power from supply to the source and the maximum power under the maximum transfer condition. So here the voltage value is equal to 30 volt, R1 is equal to 15 ohm, load resistance value unknown value, R2 20, R3 30, R3 10, R4 5. Okay, so find out the maximum power. Okay, so first to find out the Thevenin's VTH. So first to find out the VA means voltage crossing the R1, R2 resistance. VB means voltage crossing the R3, R4 resistance. So find out the first VA value. So VA is equal to total voltage into R2 resistor divided by R1 plus R2. Substitute that value, find out the VA is equal to 17.1 volt. Same the procedure, find out the VB value also 10 volts. So now you know already VA value and VB value. Substitute VTH is equal to exactly VAB. So VA minus VB, that is the VTH value. Here the VTH value means voltage across the load resistance is equal to 7.14 volt. That is the voltage value. So now find out the R equivalent or otherwise RTH value. So short circuiting the voltage source. So find out the RTH value. Here R1, R2 parallel of R1 plus R2, R3, R4 parallel of R3 plus R2. Substitute the value. RTH value is 11.90 ohms. So you know already VTH value and RTH value. So find out the power value, maximum power. From the maximum power transferred to the load to load resistance to source resistance that deliver the maximum power. So here RTH is equal to 11.90 means exactly RL is equal to also 11.90. So the maximum power formula you know already. VTH square divided by 4 RTH or otherwise RL. Substituting TH value, VTH value and RTH value, find out the maximum power value is equal to 1.07 watts. So in this circuit, the maximum power is delivered to the load is 1.07 watts. Okay, this is the one example. You know another example. Okay, this is the open. Okay, next. Thank you.